Good afternoon, ladies and gentlemen. My name is Joe Guerrera, Executive Director of the Lehigh Valley Heritage Museum, the Lehigh County Historical Society. In introducing today's speaker, I told him earlier when he arrived, there are two people that are very difficult to introduce. In fact, they're impossible to introduce. That's Dr. Kern, who's the state archaeologist at the State Museum in Harrisburg. He was here last week. I don't spend a lot of time introducing him because he doesn't like it. Everyone knows how well credentialed he is. Peter Kern is of, I would say, equal qualifications. Peter Kern is one of these guys that whenever you sit and talk to him, about 3 minutes into the conversation, you realize he knows more than you do. So you do a lot of listening. And I do a lot of listening, and I shake my head yes, like I know exactly what he's talking about. So I shouldn't tell him that, but it's true. But what I can say is this: Peter is a esteemed chemical engineer. He's also been involved in astronomy for probably 50 years, more than 50 years. His wife, we were talking at lunch, was one of the first people, Carol, who's here today, who's the librarian for the Western Pocono Community Library. In fact, she helped to create the entire institution along with Peter. Was one of the first people in the United States to graduate from an astronomy program. So they really understand astronomy, they understand the space program, and with that I can say that Peter Kern has a distinguished career as a president to a hospital, senior vice president for the New Jersey Zinc Company. He ran the large Ogdensburg mine in Ogdensburg, New Jersey, which was a well-known repository of zinc. He has done many things. He's extremely active and well-known in the Lehigh Valley. Let's give Peter a wonderful round of applause, and he'll take over.
Good grief. I didn't realize there were that many people here.
Is it working for you?
It's on now. Can you hear me in the back?
Yeah.
Good. Good. I can get rid of that. I think I'm okay. How's that? Is that all right, Zach? Yeah. I have a tendency to project anyway. I get carried away, especially after introduction. I don't know where he digs all this stuff up, but I think he makes it up. I know you're all here to hear a little bit about what happened in 1969. How many of you have seen the Right Stuff, the movie The Right Stuff? How many have seen Apollo 13? How about Apollo 11? Okay, all of you people can go. You don't have to stay, because I'm going to talk about music. Fly Me to the Moon was written in 1954. Kate Ballard was the first one to sing it. And does anybody know what the original title was? Hold My Hand. Hold My Hand. And, well, if you look at the lyrics, you'll find out why. It shows up in the last 2 lines of the lyrics. But he changed the name to Fly Me to the Moon. He took it to the publisher, and the publisher said, I don't like that. He says, Take Me to the Moon is better. He said, no, Fly Me to the Moon. It's either Fly Me to the Moon or nothing. In the next 40 years, that's been recorded over 400 times by different artists. So you get an idea, it's popular. So much for Fly Me to the Moon. I chose the title simply because I thought it was catchy, and Joe thought it was a good title too. So, but I'm going to really talk about what got us there. And I'm going to start with a slide that I used at the last presentation I made here. It's Einstein's comment that imagination is more important than knowledge. Knowledge is limited by what we know. Imagination is unlimited. So with that, I'm going to move on to my next slide. Oh, how did that get? Anybody know what that is?
No.
That's the Minotaur. Why am I starting here? Because I want to start at the beginning. And getting to the moon started not just a few decades ago. It started in ancient Greece, actually. Homer talked about this. This is the Minotaur. This is a monster, half man, half human, half beast. The king of Crete, Minos, the king of Crete. I'll get into the story about how he wound up having this guy as a stepson, but the point is, he was a very vicious person, and he wanted him locked up, so he hired this very sophisticated engineer by the name of Daedalus and his son Icarus, and said, I want you to build me a device that will keep this guy in check. So they built, on the island of Crete, a labyrinth. You know what that is? Basically, it's a fancy maze. You couldn't get out of it. It was so sophisticated, it was supposed to be impossible to escape. And of course, the king, because he was never true to his word, he was going to pay for this, had Daedalus and Icarus incarcerated inside the labyrinth. So what happens? Daedalus, being an engineer, he says, I have a way to get out. I'm going to create wings. We're going to fly. And this is where it all starts. He creates wings out of feathers and wax, and he and his son try to fly out. Now his son, he tells his son, don't fly too high, because if you get too close to the sun's going to melt the wax, and you're going to fall into the sea. And as a matter of fact, that is exactly what happened to poor Icarus. Daedalus managed to fly on, landed in Sicily, and the story goes on from there. So much for mythology. But it shows you what imagination has to do with getting from a point of being earthbound to being on the moon. I'm going to skip ahead a couple of hundred years, actually a couple of thousand years really, to Leonardo da Vinci in the 1500s, early 1500s. The Dark Ages between, let's say, the beginning of the Christian era and the 1500s, not a lot is known about it. They call it the Dark Ages for a reason, because there really is not a lot written. Leonardo developed this sketch. I don't know what it looks like to you, but it looks like a rudimentary hang glider to me. And Leonardo did over 500 sketches of various devices to be used to fly. None of them flew because they were all based on manpower. And then he realized that there wasn't enough power in a human body to generate enough speed to get these airborne. So although it was, he was very, shall I say, ahead of his time, he made these sketches, and some of them, as I said, you know, that looks very much like a hang glider or a paraglider today. After Da Vinci, we get into the real crux of, shall I say, mathematics and astronomy with a gentleman by the name of Kepler. Kepler was a mathematician, scientist, an astronomer, and he developed a series of laws. This is what he looked like. He was very well educated. He took a lot of the data from an earlier astronomer by the name of Tycho Brahe, a Danish observer who still believed at that time that the Earth was at the center of the universe, but he did a lot of systematic observations of the planets. And Kepler came up with a series of laws that we don't know what the import is now, but obviously in the future it will be. They found out that when a planet moves around the sun, it sweeps out equal areas depending on how fast it moves. So it moves faster here, it moves slower here, but these areas are the same. So what? What does it mean? Well, it means a lot when you want to navigate among the stars or the planets or even Earth to Moon. So this becomes very important. Kepler came up with three basic laws, and I'm not going to get into them because it's not germane to the subject, but I wanted to let you know why we're building towards this scenario. I'm not going to tell you about what happened on Apollo 8, 9, and 11, and 13, because we've all seen the movies. We've seen the movies. I don't have to tell you. But I want to give you some idea of how we got there and why it's important to know this. Galileo comes along, and they all look alike. They all have beards. He was really well ahead of his time. He was the person that came into being when the telescope was first in its infancy. He did a lot of observations of the planets, especially Jupiter and its moons. He attempted to determine the speed of light. He had this great idea. He put two people at different locations about a mile apart with lanterns. They had their little hourglasses set. And then when one opened his lantern and let the light shine out, the other person was supposed to open his lantern and let the light shine out. And he'd see how long it took to get from one place to the next. Well, obviously, anybody who knows the speed of light knows that as soon as one fellow opened his, the other fellow opened his. And all he could say was, well, light was about 10 times faster than the speed of sound. The speed of sound is about 700 miles per hour. Light is 186,000 miles per second. So he wasn't even close. He wasn't even close. But he did do a lot of work on gravity. And I know we're probably all familiar with the Leaning Tower of Pisa. And he dropped two balls, different weights, and found that they both hit the ground at the same time. Now, Aristotle had predicted that the heavier one would hit the ground first. But he found out that heavy balls and light balls fell at the same speed. Now, that didn't necessarily mean that a feather was going to fall at the same rate as a steel ball, because the air resistance is involved. But certainly if he took two balls of different weights, same material, one being twice as heavy, they both landed on the ground at the same time. This was the basis for the next guy, Isaac Newton. Newton said, hey, I developed these laws that determine how objects move, gravitational laws. And he said the reason why he did that, or how he did that, was really he said, I stood on the shoulders of giants. And certainly Galileo was one of them, because Galileo provided a lot of the background for Newton. And you can see we're getting compressed in time. You know, we went from 1500 to 1610, and then we're going to maybe 1687. Things are starting to gel. I'm going to talk about this a little bit later. I'm going to talk about this is my version of Moore's Law. And anybody who knows anything about Moore's Law will know where I'm going with this one. But Newton did tremendous work which allowed us to predict motion and cause and effect. Each action has an equal and opposite reaction. De Rosier, 1783. Anybody know who he was? Frenchman. Pardon?
Hot air balloon.
Hot air balloon. Good. Give that man extra bonus over there. There it is. He was the hot air balloon man. They still wanted to get away from the Earth. They still hadn't quite figured out how to do it. And so de Rosier came along and he realized that if you heated the air inside of a balloon, it was less dense than the surrounding air and it would rise. And we still have hot air balloons today. We see them all over the place, not the least of which here in the valley, in New Jersey. New Mexico, if you really want to see them, you go to New Mexico. But this is rudimentary flying back in its early days. Now we get a little bit further along. We get to the Wright brothers. 1908, we all know what happened on Kitty Hawk. Wilbur and Orville, bicycle manufacturers, but they had some knowledge of aerodynamics. And aerodynamics basically involved how we design something so that we get a certain amount of lift. And they came up with what we would call one of the first airplanes. That's 100 years ago. We don't really, it's almost within the lifetime of people today that this was in existence. 100 years ago, that was what an airplane was. Today's version, the Airbus, it's 100 years since we went from this to this. It's hard to imagine. I don't think anybody, I certainly don't think Wilbur and Oval thought back in 1908 that they could achieve that type of solution. Now, you notice the time periods are getting more compressed because now we're becoming involved in not only aerodynamics, but ballistics. Ballistics is a little bit different. You shoot something up, you calculate its trajectory, and eventually you learn how to predict where it will land. And we had our friend Mr. Goddard. Now Goddard was an engineer, he was a professor. He went to Worcester Polytech in Massachusetts. He really designed, he was the first liquid fuel rocket designer. The Chinese had always been experts in rocketry, but that was solid fuel. That was solid fuel, basically using gunpowder or the like. Goddard had over 214 patents. The biggest problem with Goddard is he was a very secretive person. He didn't want to tell people much about what he was doing. It's unfortunate because he never really received the recognition in his lifetime for the rocketry work that he did. He used gyroscopes, for example, to control his rockets. And he could have accomplished a lot more if he'd been a little bit more collegial in his point of view. That's first liquid fuel. That's an amateur rocket. Now, this is today's amateur rockets. Can you imagine? We've gone from this, 1926, to today's amateur rockets. These are amateurs who are launching these things. You have to have a permit, of course, to do it. And you have to have a place like the salt flats of Utah or someplace in New Mexico where you can launch them. But this is today's amateur rocket. You know what that is? That's V2. We're now into World War II. The Germans developed the V2 rocket, used them extensively in the Blitz in England during World War II. It was a very simple design, at least theoretically, but again, ballistics was involved. They realized that if they could shoot it up in a certain direction, they had some guidance on it, they could get it to come down in London, and they did a tremendous amount of damage with these during the war. It's not something that anyone's ever proud of in a shall I say, social sense, but from a technical standpoint, it's something very important that taught a great lesson. And after the war, the United States scavenged up as many German scientists as they could, not the least of which was Werner Magnus Maximilian Freiherr von Braun. Now, that doesn't impress you, not much will. Certainly brilliant man in his 20s and the early 30s. He was a major influence on German rocket design. The old argument was he a member of the Nazi Party? I think everybody who lived in Germany or was involved in any of these things had to be part of that party, but I'm not going to get into the political aspects of it. But he was a brilliant man. He became the chief architect of the Saturn V rocket that got the Apollo astronauts to the moon. I haven't shown a picture of Albert Einstein, but I probably should at least mention that his relativistic effects have to always be taken into consideration when we're talking about space travel. But I'm going to just skip now, and you notice how we're now down to very small increments in time. Sputnik 1 and Sputnik 2. That was the first Sputnik that was launched into space. It was done on October 4th, 1957. It scared the living daylights out of the Americans. Nobody was prepared for this. I don't mean to say that we weren't developing a space program ourselves, but Sputnik certainly did scare us. It frightened all Americans because we were in the midst of the Cold War, and this was more evidence that the Russians were ahead of us in matters such as space exploration. This was done on October 4th. It weighed about, I think about 200 pounds. It was a heavy piece of equipment, but it had no function. It had no experimental function. There were no sophisticated devices inside of it. It was basically just a cannonball that they shot into space to prove that they could get it into Earth orbit. And getting it into Earth orbit meant getting a speed of somewhat in excess of 7 miles per second. That's the orbital velocity to get something into orbit. That sounds like, it doesn't sound very fast when you talk about the speed of light being 186,000 miles per second. But that was quite an achievement back in 1957. A month later, they launched the second one, Sputnik 2. They had a dog on that one. The dog lasted, I think, a day or two before it perished. The satellite eventually burned up on reorbit. This really caused us no end of distress. And they had 2 of them in orbit, and we had none. So we were going to rush our program, and we got into the Vanguard program. Now, I don't know how many of you can remember, but I remember watching this on television. We were all sitting around the television in December 1957, waiting for the launch of this Vanguard satellite, which weighed 4 pounds. It was a little more than, let's say, a softball. They counted down, they got down 5, 4, 3, 2, 1, ignition. The thing got about 4 feet off the ground and came right back down and crashed in this big, massive flame. It was the most embarrassing moment, I think, in the history of the space program. They did eventually, a couple of months later in February, they did get a satellite into orbit. It was an experimental satellite, and did a lot of work on determining what the Van Allen belts were. And I'll talk a little bit about the Van Allen belts later and why it was important. But one thing that the Americans were keen on was learning how to get people up there and keep them safe. Now, the Mercury program began in 1958. This is the program that we said, okay, fine, we really want to get the space program moving. And they put together a team of seven astronauts. I'm sure you all remember them in various forms, especially if you've seen the movie The Right Stuff. You had Alan Shepard, Gus Grissom, Scott Carpenter, John Glenn, Gordon Cooper, Wally Schirra, and Deke Slayton. They were great ambassadors of the program. They were all clean-cut, white American men. Okay? That's what they wanted at the time. And they were all college-educated. They were all members of one or another member of the armed forces. It was a very, shall I say, exclusive group. Of course, no women, no people of color. This is what we were looking for at that era. It's a different time, different era. But those 7 astronauts began the program, the Mercury program. This was a Mercury capsule. Again, you find that Alan Shepard went up on May 5th, 1961. It was a suborbital flight. They lifted off from Cape Canaveral, which is now called Cape Kennedy, but Cape Canaveral at the time. And the suborbital flight brought them down safely in the Atlantic Ocean. And it caused John Kennedy, president at the time, about 3 weeks later, to issue his famous challenge. The challenge being to have the program ready to take a man to the moon and return him, and you notice it was him, and it was a man, return him safely to Earth by the end of the decade. In other words, by the end of 1969. It was the decade, at least they thought the decade ended on December 31st, 1969. So, this program was started, the second one was Gus Grissom. Some of you may remember that when Grissom landed, again it was a suborbital flight, he landed and the hatch blew off prematurely. Some say he blew it off, others say it was a fault in the system. The capsule subsequently sank. Grissom was not lost, he was obviously saved. And they subsequently recovered that capsule years later at the bottom of the Atlantic. The program continued. The next one was John Glenn, and we all know how successful that was, and that really gave us a tremendous boost as far as the Mercury program was concerned. Now the original program to get a person, or a man to the moon, was designed basically in three parts. You had the Mercury part, you had the Gemini part, and then you had the Apollo. The Apollo being the culmination. Now, the next part was the Gemini program, which began around, obviously when I put a date up there like 1966, the work began a lot before that, because a lot of this was interrelated. You had work going on one program and the other programs simultaneously. But the first Gemini program, and we all probably remember with great distress the loss of the three astronauts, Grissom, Chaffee, and White, in that fire. That's what the capsule looked like when it was in orbit eventually. But Apollo 1 was lost on the launch pad. It was a tragedy that kind of had repercussions all around the space program at the time. It could have destroyed the space program. It could have set it back a decade. Instead, the engineers and scientists and the Gemini and Apollo teams got together. They worked even doubled their efforts. They finally got the Gemini program into orbit. There were no Gemini 2 and no Gemini 3, but they had several more Gemini programs. They were all successful. They were two-man crews. Two-man crews on Gemini. And I'm going to show you a little later, I think one of the last slides, the relative sizes of these capsules, so you can get some idea. We move on from the Gemini program to the Apollo program, 1967. Started in 67, really ended in 72. The key, obviously, is 1969. After having lost Apollo 1, they really accelerated the program and made as many as 4 launches in a very short period of time as we were getting into 1969. And the most, perhaps the most, well, let me get back to this one. I want to mention this. This is one of the problems that goes unseen in the work that was done. And these are the Van Allen belts. This is the Earth right here. These are belts of highly charged particles. They're charged particles. They're captured from the sun. They're protons and electrons that circle the Earth, and they're potentially very hazardous to astronauts. So the real question is, how do you protect astronauts from the Van Allen belts? The logical way to prevent them is don't go through the belts, go around the belts, which to a great extent they did. They range from about 1,000 miles out to about 60,000 miles from the Earth, to give you an idea. So it's very difficult to avoid them in their entirety. But they did find that because they're particles, it's not X-ray type of radiation. It's mostly protons and electrons, and they can, with very simple shielding, they can prevent much damage from being done to the astronauts as they fly through them or near them. But these are very important in the early design of the capsules, because they wanted to make sure that the astronauts would not come back with any serious injuries. This is the first Apollo 3 capsule, and that is perhaps one of the most famous photographs ever taken. That was taken Apollo 8 when it flew over the Christmas holidays in 1968. It flew to the moon. Frank Borman was on there. He read a Christmas message on Christmas Day. Does anybody remember what the Christmas message was? Genesis 1. In the beginning, God created the heavens and the earth. Politically incorrect today, but very, shall I say, appropriate at the time. And who was going to criticize him? I guess they could have cut him off. I guess today they might have bleeped him. But times change. Times change. Now we get to July 1969. And between Apollo 8 and Apollo 11, you had Apollo 9 and 10. And what they had to do with those two was determine whether they could safely extract the LEM and recover the LEM. Because that was, you were going to get one shot at this, and if it didn't work, you were in love. The LEM was designed to have only one system, propulsion system. If that propulsion system didn't work, the LEM didn't work. If the propulsion system didn't work properly on the way down to the moon, it crashed. If the propulsion system didn't act properly on a return voyage, the astronauts were stuck on the moon. There was no, you couldn't hail a AAA guy and ask for repairs. So when we landed on the moon, and these are the iconic photographs, this is why I say you're really, I don't want you to be disappointed, and I'm not showing you any flaming rockets going off and things of that nature, because this really isn't a story about those days. It's a story about how we got there and why we got there. This is, again, an iconic photograph showing our flag indicated in a furled position as if the wind was blowing it. They had it frozen into that position so that it would look like it was waving, but there is obviously no air on the moon, so that's not the case. So, hang on. Here it is. I just want to give you this example of the approximate scale of the rockets that we're talking about between 1961, this one, 1961, this is the Mercury capsule. 1966, this is the Gemini capsule. 1969, this is the Apollo capsule, and that's the rocket that got it there. That's the Saturn V that I mentioned earlier that Werner von Braun was instrumental in helping to design. We're talking about ballistics. In other words, you've got literally have to shoot it up to get it far enough above the Earth so that the force of gravity will not return it to Earth. It will allow it to go around the Earth, and eventually you can fire another smaller rocket and get it on its way to the moon. But this gives you a rough idea, and this is to scale, by the way, of the different sizes, from this one to this one. I think that's an impressive photograph. What's important about this? Well, I said earlier on I want to talk a little bit about Moore's Law. Anybody know what Moore's Law is? It's, go ahead, give us a quick, give us a summary.
The expectation that the speed of computer microprocessors will double every, I forget what the.
Well, you're right. That's exactly what it was. Gordon Moore was one of the he was probably the first CEO of Intel. He was one of the co-founders back in 1965, and he predicted that the number of transistors on a circuit board. Now, a transistor is just really an electrical device that has switches that open and close, but they're very, very tiny. He predicted that the number of transistors on a circuit board, he said they're going to double every 12 months. Originally said that. Then he modified that a little bit to every 18 months, and then eventually it's every 2 years. Doubles every 2 years. Now, if you take doubling of every 2 years from the time he stated that in 1965 to the present day, you're talking about 100 million times more computing power today than you had in 1965. It's an unbelievable increase in computing power, which is why we have, where's that thing I have in my pocket? Oh yeah, here it is. This has more computing power than the computer on the Apollo 11 flight to the moon. It's unbelievable. It has more computing power. You don't realize the beauty of the designs that they've come up with. And they estimate that this law will hold at least until 2025. Now after that, what's next? You just can't keep doubling and doubling and doubling. Of course, sooner or later, you wind up with more atoms than in the universe. Not too much further after that. But they say there are new things on the horizon. New computing technologies that we haven't even explored yet. And this is why, I guess the question is, why was it important to go to the moon? We didn't get anything other than a few rock samples back from there. We had a lot of, shall I say, pride in what we accomplished. We felt, shall I say, impressed with the ability to get there. But we say, what is the next frontier? The next frontier, we all know what the next frontier is. This is an actual photograph. Mars, actual photograph of Mars. Those are tracks left by the Mars rover as it's traveling through. Took a nice picture of the Martian landscape. It is not unlikely that in the lifetime of some of us, probably not all of us, but in the lifetime of some of us, certainly in the lifetime of the children and grandchildren that might be here today, they will see someone on Mars. But the same challenge that Kennedy put forth will have to be addressed. Do we want to just send somebody to Mars and let them expire there and say, yes, we did get someone there, or do we want to be able to send someone to Mars? And I say someone, because this time I think there'll be a much more diverse crew than we had in the Apollo missions. Send someone to Mars, and we want to be able to bring those people back to Earth safely. So we still have a lot of work to do with the technology, but it's not impossible. You've all seen, how many have seen Martian? See? You should see The Martian. It's a good movie, actually. It's not bad. It's a little bit romantic at the end, but it's a good technical movie. I think that if we persevere and we don't allow the politicization of some of these projects to get ahead of us, people say, why Why do we do these things? We do them because it's important to do them. It explores new frontiers. It enables us to come up with devices such as the cell phone that we take for granted today. But all of this technology came out of the work that was being done on sending a person to the moon and getting that person returned home safely. That's it. It's about a wrap, folks. Joe tells me I get 40 minutes to
No,
talk.
now you're going to take the questions and answers.
Oh, to questions.
This is a very astute crowd.
I can't answer any questions unless they're on music. If they're,
And there's cosmologists, we have a few nuclear physicists who want to talk to you.
Questions.
But really, the Q&A is what I would like to hear, and I'd like to ask the first question, if I might.
Go right ahead.
And I listened to Carl Sagan. One of the things that we've grown up with is it doesn't matter how much the space program costs, because the residual benefit to the United States is so great that it's remarkable. Now, Carl Sagan disagreed with that proposition. He said that's a weak argument. And what do you say to that?
Well, yeah, his argument probably is that it's the desire to expand our knowledge that's important, and it's not to get a material benefit from that. And I think any true scientist probably would say the same thing, that it's really the knowledge that's important and not the commercialization of it. But the commercialization is what pays for it. And if we didn't have the ability to take these to the next level, in other words, what good was a wheel if all we had was one wheel? What good would a wheel have been if we only had one wheel, until somebody figured out, well, if they put an axle between the two, they could use it to roll things. And if they put two axles on, one in the front, one in the back, then they had four wheels and made it even easier. This is what happens. When we come up with the knowledge, we then come up with the commercialization or the improvement of that knowledge. And then we move on to the next step. Now we've got a cart with four wheels. What's the next step? The next step is maybe we can motorize that. And we eventually wind up with cars and trucks. But it takes time. And time is something that, well, as a society, we have plenty of it. As individuals, we'd like to see it go, move along a little faster. But as a society, we have plenty of time. I don't know if I answered your question, sir.
When did they go from solid rocket fuel to liquid hydrogen and liquid oxygen engines? Did you know about when that happened?
That would really be in the in that period from, let's say, 1940 to present day. And I think they realized that the ability to use liquid fuels is much more controllable. They flowed. You could control the burn, which is much more difficult with solid fuel. Solid fuel, once you've ignited it, it becomes difficult to control. Now, if you want control, that's one of the key reasons, I think, for having liquid fuel. I don't know if that answers the question, but basically, I think that's about when it started, though. From I would say mid-40s until present day. Sir?
What's next in the space program?
What's next? Mars. Mars is next.
More specifically, the president has
Space
spoken
Force.
about a space force.
Yes, well, I think that the question is how we get there, I think involves the answer to the question you asked. There are many stages and steps, just as there were with the lunar program, which started out with basically the Vanguard failure, followed by a few rudimentary successes, and followed by eventually the Mercury, the Gemini, and the Apollo programs. It's going to take many steps. And I think that's one of them is obviously building the type of facilities up there that can serve as jumping off points for programs. But it's going to be complex. It's not something that's going to be simple. Ma'am?
How do you feel about a lot of this going privatized?
Privatized? Elon Musk, mean? Brilliant man. A little wacky, but I think a lot of people are. But I would say we should always look to the government to do things that private industry can't do, simply because the costs are overwhelming. But once the costs become, shall I say, I don't want to use the word commercially, but I think that once they become commercially manageable, then I think industry, privatization can work. I don't think the government has to send people to the moon if Elon Musk can do it and do it safely. So I think there's a balance. The initial work, if you look at many government programs, whether it's cancer studies or medical studies or anything of that nature, a lot of it starts out at the government level and eventually winds up in private hands because it can be moved along more efficiently then. Question?
What do you say to people that insist that the lunar landing was a hoax?
Go back to West Virginia.
Well, I mean, politely, I should say.
Stop going InfoWars.
I think that there will always be a certain amount of conspiracy theorists. And I think there are those who believe that it never really took place. I say the preponderance of evidence says otherwise. That's all I can say. Sir? Sir?
The lunar rover landing site, this was carried on the History Channel, so I'm not picking it up as some kind of weird thing. But where it landed was not too far from a number of megalithic rocks, approximately 80 feet tall. Have you ever seen those photographs?
No, I haven't. Can't say I haven't. You're talking about on the moon.
It was on the History Channel last Monday night.
Well, you know, there have been pictures of Mars showing faces. Hey, we've always talked about the lady in the moon. I mean, if you look at the seas, the Maria on the moon, they do have a certain image. But I think if you look at the Earth itself, you'll probably find many places that have similar, shall I say, naturally occurring phenomena. Now, if you go down to Peru and you see all those things that were, yes, if you see the things that those were drawn. We know those were drawn. Why they were drawn, I'm not one of those ancient aliens buffs, but who knows? It could have been. They might have had reason to believe that there were people from from other areas that were coming down. Sir?
Yeah, I was wondering if we had been less successful at the end of World War II with Operation Paperclip, getting the German scientists that had worked in their rocket program. Do you think we still would have beaten the Russians to the moon, or how critical was the inclusion of their expertise in getting us there?
Well, there were 1,600, supposedly more or less 1,600 scientists that we scuffed up right after. In fact, we fought to get to them before the Russians got to them. I think the Russians had similar designs, and they did get some of the top German scientists. It's not a question of them being German. It's a question that they were scientists that had a certain amount of expertise. And I think the same thing would have been true if it had been, the roles had been reversed. If the Germans had taken over us, they probably would have wanted to get some of the American scientists. It's just a question of that it was brain power that they were looking for. And I think without those 1,600 scientists, it would have just taken a little bit longer. But eventually, I don't believe that they were any brighter or smarter than any of our scientists, except that there was a nucleus of them that we could grab our hands onto at one time. And we certainly didn't want the Russians to do that. Start with the blue hat first, and then the gentleman next to you.
We talked a lot about rockets, and you pointed out that the Soviets were ahead of us in rocket technology, and that's true. But the thing that got us ahead of the Russians enabled us to land on the moon that the Russians didn't have is computer technology. That was the big difference. That was the main component that we had that they didn't have. And in fact, there was a suitcase-sized computer that was aboard the LEM, which not many people knew about. It was developed by IBM, and it was on the limb, and that was what enabled us to land on the moon. Of course, they had a little problem during descent on the first landing, but they worked that out. And I, in fact, had the pleasure of meeting one of the engineers that built that computer.
Well, I think the LEM, as I pointed out, the LEM was, it was go, no go. If it didn't go, there was a problem. There was a problem. If that LEM engine didn't fire, what was next? I'll tell you what was next. You want to know what was next? I've got a book here. It's called Speeches of Note. Anybody ever read it? No, good. Good. So you didn't read what's out there. This is a speech. When I'm just going to read the intro. When the Los Angeles Times reporter visited the archives on an unrelated, National Archives on an unrelated research trip in the mid-1990s, he inadvertently uncovered and later published the text of a speech written 25 years earlier for President Nixon. It was a haunting announcement that Nixon thankfully never had to deliver. It was written by William Safire. I don't know how many of you. Safire was a great writer. He was a phenomenal writer. He was a New York Times writer. He was one of Nixon's speechwriters. And it was addressed to the Chief of Staff. It was dated July 18th, 1969. Okay. Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace. These brave men, Neil Armstrong and Edwin Aldrin, know that there is no hope for their recovery, but they also know that there is hope for mankind in their sacrifice. And it goes on for a page and a half. This was the letter that Nixon, or the speech that Nixon was going to have to give if that lunar engine didn't fire. He didn't have to give it. A lot of people don't know it exists, but it exists now. They found it in the archives, and it's interesting to know that you have to have someone write this ahead of time because you can't speak off the cuff. Sir?
Yes. In 1969, we landed on the moon. Is there a reason why that we've never wanted to go back and 50 years has gone past and we've never wanted to get back on to the moon? Half a century?
If people think it's routine or ordinary, they lose interest in it. We have a desire to know things that we don't know, not to know more about things we do know. And I think it's that simple. It became, with the success of Apollo 12, and then the failure of Apollo 13, but the success of 14 and 15, it was like, why bother going back? We know everything there is to know. Well, it's not true, but I think that we've taken a respite. But now I think we're moving on to that new frontier. This gentleman has been very patient.
What prompted President Kennedy to issue this challenge? Like, who was advising him, and how was that received?
Well, I think what prompted him to issue the challenge was the success of the Alan Shepard flight, which was like 2 or 3 weeks before. Alan Shepard went up on May 5th, 1961. I know the date; it's burned in my memory because my Ken Burns right here, the person that did all the work for me, it's a year before we got married on May 5th, so we know exactly. And I think we know where we were on that date too. So I remember that quite vividly. But I think that was what caused him to issue that challenge. I don't think he really fully understood the implications of what he was saying, but it roused the country.
I think there was another aspect to
Go
it.
ahead.
As you said, in the late 1950s, with the launch of the Sputniks, Americans were scared to death about how the Russians were ahead of us and looked like they were beating us at all these things. So he changed the goalpost. He changed what the race is going to be, the one that the Russians hadn't accomplished, and that he was gambling that the American technology and know-how
We'd get us there first. No, I agree. It was a certain amount of nationalistic pride, yes.
You think the Chinese are changing the goalposts now that they've landed on the back of the moon?
Well, I think what we're learning really is that nobody has a monopoly on brain power. We have the ability, and I think I said it at my last presentation here about 6 months ago. I said the greatest contribution to science in the last 100 years has been the unlocking of the elimination of the biases against women as scientists. I think we're going to find out in the years ahead that more advances are going to be made, proportionally more advances are going to be made from the minds of women than from men. Because we have been literally, we have frozen out half of the brain power in the world by the bias against women in a field of science. I think that's changing, and I think you're going to see tremendous changes in that. There is no, shall I say, monopoly, gender monopoly on wisdom. And I believe that we're going to see both the Americans, the Chinese, the Russians, the Indians, certainly the Indians. I mean, again, it's not a question so much of whether they're smarter, but it's the larger countries that have a greater source of individuals. Obviously, if you have 300 million or 500 million, you're going to have a certain amount of people that can do the job. One last one here.
Well, maybe the most controversial. Do we spend billions and billions of dollars on that? Or do we divert that to medical research for what's troubling mankind today in medical diseases? What? I mean, you got your smartphone, you got your computer, but you can't figure out the basic problems of Parkinson's, Alzheimer's disease, heart disease, diabetes. You can't figure it out.
Well, the only thing I can say is that many of the technological improvements in healthcare and medicine today came out of totally unrelated work in other fields. They didn't come out of, somebody didn't sit down and decide that they were going to come up with a better prosthesis for a knee replacement or a hip replacement by doing it strictly in medicine. It evolved through other stages and other technologies. I think that by exploring areas and using, shall I say, those dollars, as long as they're not disproportional to the efforts in other fields. I think we've got to realize $1 billion, with all due respect, $1 billion today is what it was $1 billion 10 years ago. But the point is that that money eventually will probably return itself in years well beyond our lifetime in other advances. I can only hope that that's the case because I think it's happened before and I see no reason to think it wouldn't happen again.
Before we conclude, is that your last question, Peter?
No, that was my last question, but I wanted to give kudos to my Lou Rita that sits here. my Ken Burns. You know, I dig these things out and I say, here, Carol, take care of these for me, put them into the computer. She's the one that does all my...
well, why don't you stand up real quick, Carol? We want to give you a... As a speaker's gift for you, there's not a lot I can get. In fact, you're one of those people that it's very hard to get something for. But we do have a used bookstore. And so it's not an expensive gift, but I think it's very appropriate. I didn't see your name in there. And it's the 100 most influential scientists of all time. That is your speaker's gift for today. Children that are here, we're going to give the children a free record. We gave one to a child and he said, I don't have a record player. Well, this is history. And I said, you ought to just get it and put it in your bedroom. And maybe one day you will get a record player. So, you know, If there's so any children that are here, we're happy to give them one of these records, courtesy of Blue Rita. I think this is very insightful. The only thing I would add to this, I should say, is that 50 years ago when we landed on the moon, I thought we would be further ahead by today.
In many respects, we are. We just don't realize in what areas of science we are further ahead.
Well, on that, let's give Peter Kern a nice round of applause. All of you for being here today, and I don't want to get ahead of myself, but I'm going to say something else, and that is, if you have a child in the house, and he's not here today, and you want to get one of these records, you think he needs one, we'll give you one too, because we want to get that out there. So listen, we're here for all of you. We're only as good as all of you and all of the members, you know, like they talk about it, like public television, NPR, PBS. They're nothing without members. So thank you all for being here. We next week have Harry Trexler, and I can't say enough good about all of you. Don't they deserve a round of applause?